regions, you are given an m times n matrix board containing the letters X and O. Capture regions that are surrounded. Connect a cell is connected to adjacent cells horizontally or vertically. Region to form a region. Connect every O cell. Surround a cell is surrounded with X cells if you can connect the region with X cells, and none of the region cells are on the edge of the board. A surrounded region is captured by replacing all zeros with O's in the input matrix. So, for example, here, this is our border, and so since we have this as our original border, and so we have to convert all these other x's since they are surrounded by x's to x, and this one was left alone because it was not surrounded by x's, and this one is this one is simple. A has an x, so our output is x. So here it says do not return anything, modify board in place instead. So there's no need to return anything, just modify our border. So let's see how we're going to do this. So we'll do this by solve. We'll solve it. We'll solve it by using a depth first search. So how will we do this? So let's make edge statement. So if board, if not board, or board zero index is or not, return. Now let's make our m and our row and our so let's make a len border and our column as len border 0. So this will be so this will be m will be 1, 2, 3, 4. That's the end of board. That's our row. So our board is the first row. It will go by counting 1, 2, 3, 4. So that's how that's our columns. So n is our columns, m is our row. So now let's make our depth first search. Let's make our depth df as helper function. So that will be def dfs, and then put r and c, and then let's check if it's within bounds and if it's O. So we'll do that by doing r if r is less than 0 or r is greater than or equals to the length of border, or c is less than 0 or c is greater than or equals to the length of border index 0. This is our column. Or border C is not equals to 0 of O. So now let's mark cell as visitor after calling DFS function. So border RC will be visited, and then let's our movements in the DFS R plus 1. This is up. No, this is down. Hold on, let me think quickly. Down. DFS R. Oops. C over here. For column will stay the same. -1 will be C up DFS R C plus 1 right DFS C -1 will be left. So that's it for DFS function. So let's move out and then let's start calling on the DFS function when appropriate, when O is the number. So letter. So let's check for R in range of M if border RC R 0 is equals to 0 DFS let's call in the DFS R and 0 if border R and then C, hold on, N -1, so that's our column. Let's call on the DFS function again. DFS R and -1, and then for C in the range. In range of N if board N -1, hold on, no 0, let's start from 0, and then C DFS 0 C if board N -1, oops, M, not N, and then C oops, forgot to compare these equals to zero. Copy and paste these. Zero here also. So now let's call in the DFS function our -1 C. Now let's make our new board. So now let's change visited. No, let's change visited is visited to its original O letter and current O's as X. So for R in the range of M and R if no, and then also for R for C in the range of C N. So if board R C is equals to 0 no O. Let's change it. Let's make board RC equals to X. So else if board RC is equals to visited board RC will be equals to O. And that's it finally. So let's see if there's something that needs to be fixed here. Let's run it to see if there's any syntax errors. Whoa, and it's been accepted with no syntax error mistakes. So the time and space complexities are both time and space complexities are both of m times n. Space is because it's space complexity. Wait, time complexity. Hold on. Time complexity is m times n in the worst case. So let's submit it to see if it's going to pass all cases. And it's been able to pass all cases. And that's it for this problem.